This is problem number 5 on the sample test problems for test number 1. Sketch the graph of a single function f of x that has all of the following attributes. F of x is continuous everywhere except at x equals 2. Limit as x approaches 2 from the left of f of x equals 4. Limit x approaches 2 from the right of f of x equals 5. The graph of f is concave up for x less than 2. F prime of x is bigger than or equal to 0 for all x greater than 2. And finally, f prime of 7 is 0. So lots of information here. I'll tackle it piece by piece and probably end up making some corrections along the way. So first thing, it says f is continuous everywhere except at x equals 2. So it feels like x equals 2 is something special. So we'll put 2 there and just recognize that we're continuous except at that point. We'll move on to b. Limit as x approaches 2 from the left is 4. So that means we've got this point up here at 2, 4. And so I'll put a point up there, and I don't know whether it's going to be filled in or not, but I do know that as x approaches 2 from the left, I'm supposed to get to 4. So the graph does something over here on the left-hand side until it gets to 4. I don't know exactly what it's supposed to do. So right now we'll undo that temporarily. Then it says in part C, as x approaches 2 from the right, the limit is 5. So we'll go up a little bit higher, and I'll put another point over here at 5. And so at this moment, we know as x approaches 2 from the right, I'm supposed to hit that point. So it does something over here, and I don't know exactly what. So we'll undo that. And then we'll move on to part D. It says the graph of f is concave up for x less than 2. So I'm supposed to draw something that hits the bottom blue dot from the left-hand side, and it's supposed to be concave up the whole time. So let's draw something concave up the whole time, and if we need to fix that, we will. The next part says, in part E, f prime of x is bigger than or equal to 0 for all x greater than 2. So we'll translate that. If the derivative is positive, then the function's increasing. So for all x greater than 2, I need to draw a function that's increasing. And again, it needs to hit the top dot. So we'll just draw something increasing, and we can fix that if we need to. And then finally it says in part F, f prime of 7 is 0. So that means that the function is flat at x equals 7. It's got a horizontal tangent line. And so I guess that means that to the right here, we need to be careful. Maybe we can't draw something that looks entirely like we did there. We just need to draw something that's increasing but flat at 7. So let's try to draw something increasing. But as we get to 7, it's flat. So we'll put a dot out here at 7. 2, 3, 4, 5, 6, 7. And it's flat at 7, but then it needs to be increasing again the whole time. And so if you're putting this on a test or a quiz, even write the word flat just so that we really are clear about what's happening at that point. So it flattens out just temporarily, but it's increasing the whole rest of the way. And I think that's it. So let's double check everything. Part A, it says f is continuous everywhere except at x equals 2. And it is. We've got that jump discontinuity. In part B, limit from the left is 4. So from the left, we're supposed to approach 4, and we do. In part C, the limit from the right is 5. So from the right, we approach y equals 5, and we do. The graph is concave up for all x less than 2. So that's this piece right here, and it is concave up the whole time. And then in part E, we need the function to be increasing when x is bigger than 2. So that's all of this increasing, except for that one moment right there where it's flat at 7. And that's that point right there. So I think this graph takes care of all the conditions. Certainly there are other graphs that you could draw here. Lots of right answers to this one. Whether or not you fill in the point there or up above or neither makes little difference.